Alright, this is the second video of part 1 um, for 9.1 and just finishing up the lesson with these last two sections. So in the first video you saw how to plot points in a polar grid, and so we're going to connect polar coordinates to rectangular coordinates that we're used to. So this question says, what is the rectangular coordinate x comma y given the polar coordinate of 6 comma pi over 6. One thing I want to first mention is kind of going along the lines of, remember ASTC, right? Okay. Okay, because so r comma theta here, we know that theta is pi 6, that's in quadrant 1, right? R is positive, it's a positive 6, so we know we're staying in quadrant 1, okay? So meaning this coordinate itself is in quadrant 1. Alright, so you got to keep that in mind because your xy coordinate is also going to be in quadrant 1. Alright, now before we get started on this, we're also going to do a flashback here. Alright, meaning we're going to do from earlier in the unit, or not in the unit, but earlier in the semester, we learned that cosine theta is equal to x over r, and sine theta is equal to y over r, right? And so, what if we were to multiply by r on both sides for both of these equations? Because then what we end up with is here we have x is equal to r cosine theta, right? There's this relationship. And over here we have y is equal to r sine theta. Right? We're going to use these a lot. Okay? So, because look, we need an x and a y. Alright? And so first, for the x, those are dots, colon, x is equal to r cosine theta, meaning we're just simply taking our polar coordinate, the information from there. R is 6, cosine of pi over 6. And then we evaluate, right? We know that cosine of pi 6 is root 3 over 2. And we already had a 6, right? So when you work this out, okay, x turns out to be 3 root 3. When we go through the same process for the y value, okay, so we know that y is equal to r sine theta, and y is equal to 6 times sine of pi 6. Right? Sine of pi 6, we know this is what? That's going to be 1/2. Right? And so y is equal to 3. Okay? So putting that all together, right? We have a rectangular coordinate of 3 root 3 comma 3, right? And when you look at that coordinate point, that's in quadrant 1, which is what we needed. Okay? So the same thing applies for this example as well, right? R is -4 and theta is negative pi over 4. Okay, now you got to be careful though, because think about it. negative pi over 4 is here, right, in quadrant 4. So it's supposed to be here. But look at the r value. The r value is negative 4, so along this line, since it's negative 4, we actually have to go the opposite way. So it's over here. So we're actually, this is actually in quadrant 2. Okay, so your xy should be in quadrant 2. Alright, we're going to use the same equations, x equals r cosine theta, and y is equal to r sine of theta, and then you work it out. Alright, now if you want, you can pause here to try it on your own, or just keep watching, and here it is. Alright, so this is what I came up with. I have this for x and that for y. I'm going to put those together. We have negative 2 root 2, comma, 2 root 2. And if you look, your x is negative and your y is positive, which means this is in quadrant 2. Alright? And that's what we needed. So that's how you go from polar to rectangular. The last example we're going to look at is going vice versa. How do we go from rectangular to polar? Okay. Yeah, and I think the heading for this is incorrect. All right, this should read rectangular. Oops. To polar. Okay. All right. So 2 comma negative 2. Right. That is in where is that? That's quadrant 4. All right. 2 comma negative 2 is just 1. 1, 2. 1, 2. That's right here. Right. I know that one thing I could do here is to just make a right triangle. Right. If this is, and let me label this. If this is 2, that's negative 2. And by Pythagorean theorem, I can figure out what the r value is going to be. Okay. Or if you remember the special right triangle shortcut, you can do that as well. All right. If not, then just work it out. You have r squared, that ends up being 8. And r is the square root of 8, which simplifies to 2 root 2. So there's my r value. Now, since a polar coordinate requires r comma theta, right? We need a theta value. We need an angle measure. Okay. All right. Well, that's going to be the second part of this problem. Right. So remember, we're trying to figure out this angle. Okay. And so we're going to use the inverse here. Now you could do sine or cosine, but I think the easiest to use is actually tangent. We'll see why in a second. Tangent is y over x, right? And so here, tangent of theta is going to be y is negative 2, x is positive 2, and that's equal to negative 1, right? And so theta, right, is the inverse tangent of negative 1, okay? And so really what we're asking is tangent of what is negative 1. Right? Tangent of what is negative 1. And so if you know that it's the same on top and bottom, if you know that it's 1 or negative 1 for tangent, right, your angle has to be one of the 45-degree angles. Right? Okay. Now since we're in quadrant 4, okay, well I'm circling here, since we're in quadrant 4, that must mean, well, there's a couple ways that you can write it, right? If we're in quadrant 4, you can, and here I'm going to draw it like this. There's a couple ways to go about it. You can write it like this, right? That's 7 pi fourths. You can go the other way, like this, right? That's going to be negative pi fourths. Okay. I don't care which way you go, actually. All right. Yeah, I think what I had in my answer from last year is I used 2 root 2, comma, negative pi fourths. Right? Like I said, you could do 2 root 2, comma, 7 pi fourths. Okay. I'll throw in a challenge question here. What would be the 2 other ways to represent that point? Okay. All right. And then the last question, since I'm running out of time, I'm going to have you guys try this one on your own. Negative 1, negative root 3. Here's a quick setup. Excuse me. Here's a quick setup. All right, you know that's going to be in quadrant 3. Okay. Negative 1. Okay, negative 1. And then, you know that's going to be down here somewhere. That's negative root 3. You can figure out your R value. All right. If you want, pause it here and then try and figure this problem out on your own. So when you work this out, your R value turns out to be 2. Okay. And when you do the cosine and sine of this angle measure, your cosine ends up being negative 1/2 and your sine ends up being negative root 3 over 2. And when it's in this order, this is quote unquote 60 degrees, right? Meaning in quadrant 1. Okay. So in quadrant 3 though, right, your 60 degrees past 180 is 240 degrees, which in radians is 4 pi over 3. That's your theta. So your polar coordinate is 2 comma 4 pi thirds. Alright, so that's the end of this lesson. Alright, hopefully that was helpful. And then that's part 1 of 9.1.